Hello, welcome you all. Today I discuss Banker's algorithm that used for deadlock avoidance. Now we start with discussing what is Banker's algorithm. So this is actually a deadlock avoidance algorithm that ensures that the system never enters an unsafe state. It works by considering resource allocation requests and check whether granting them will lead to a safe or unsafe states. Now how it works actually: initialization. So at the start the algorithm determines the total available resources of each type. Request handling: when a process requests resources, it checks if the requested resources can be satisfied without causing a deadlock. If the system can allocate resources to satisfy the request and still leave the system in a safe state, if grants the request, otherwise it waits. Now resource allocation: when a process finishes and releases resource, they become available for allocation to other processes. Now let's look a very simple example to understand how Banker's algorithm works. So we have a given system with resources R1, R2, R3 and processes P1, P2 and P3. Now available resources for each resource instance: R1 is 2, R2 is 3 and R3 is 2, with initial allocation is shown in the table. For step 1 we have to calculate the need matrix. So look here, we have process here P1, P2, P3. The maximum need for P1 is 2 to 0 for resource 1 to 3. Similarly P2 is 0, 1, 1 and P3 is 1, 1. Now allocated initially is for P1 is 0, 1, 0, P2 is 0, 1, 1 and P3 is 1, 1, 0. Now we have to calculate the need matrix. So how do we calculate it? We just subtract the maximum from the allocated, we get the need matrix. Now to calculate the safe state, the main idea is that if we, for example, execute a process, okay, we allow a process to execute, so there will be no deadlock. For example, if we want to allow to P2 to execute, it will execute it without creating a deadlock because its all resources are available. Similarly for P3. Now on step 2 we check for states and it is safe. So we give an allocation for R2 is 2, R3 is 3 and R3 is the 2 is the maximum available resources. Now we start with a process that can execute entirely. For example, you can choose P2 or P3. For example, we choose P2, so we can easily execute P2 without creating a deadlock. So that leaves the system in a safe state. After execution of P2, the resource R2 of 1 instant and R3 of 1 instant is available to reuse it. Now after P2 we will move to P1. For P1 execution we need R1 2 and R2 is 2 and there's no instance for R3, so we available instance satisfy this, so we can execute P once. Finally we can easily execute P3. So this is the way you can run the Banker's algorithm. So main idea is that you have to look that if we allocate a resource to a process, if we do execute it, either it must be in a safe state, otherwise you are not allowed to allocate the resources. You will look for some other alternative allocation. So this is all about the Banker's algorithm. Thank you.